Yes, dear children, today we'll come to structure of carbonyl group. We saw with the preparation of aldehydes and ketones. Now we need to proceed further with the properties. Okay, so for that you need to know the structure of carbonyl group. Now what is carbonyl group? Carbonyl group is nothing but C double bond O. This is called as carbonyl group, right? Okay. Now in this carbonyl group, what you have on one side it may be carbon, on the other side it may be hydrogen, or on both the sides it may be carbon also. Okay, so I have taken carbon and hydrogen because I want to show about aldehyde group. Okay, so carbon double bond O, and then on one side this is hydrogen and one side it is carbon. So wherever there is a single bond, it is a sigma bond. So here also it is a sigma bond. But when there is a double bond, one is sigma, the other one is pi. So this you have learnt it in 11th class. This is not something new to you, you know it. Okay. Now any double bonded carbon is Sp2 hybridized. This also you know it. And what is the geometry of Sp2 hybridization? It is planar. And when it is planar, what is the bond angle? It is 120 degrees. Okay. So this is what you have to remember. Now how you got this Sp2 hybridization? See, carbon is surrounded by 1, 2, 3. 3 atoms it is surrounded by. So it has to provide 3 hybrid orbitals in order to share electrons with all the 3. So what is happening here? Carbon in the ground state is having 2s2, 2p2. And then in the excited state, 1 electron from 2s, it jumps over to 2p. And out of the 4 unpaired electrons, 1s and 2p, that will hybridize. 1s and 2p. So that is why you call it as Sp2 hybridization. And this electron in the p orbital, it is left unhybridized. This p orbital is unhybridized. And that unhybridized p orbital of carbon will overlap with the p orbital of oxygen, giving rise to pi bond. Okay. So that is p-pi bond. Okay. Now, this carbonyl group, you can show that oxygen, since it is electronegative, more electronegative than carbon, the bond pair of electron is shifting towards oxygen. With the result, carbon will get a positive charge and oxygen will get a negative charge. So what you show here, this carbonyl group in the neutral state, it is getting converted into a dipolar state. Dipolar means separation of charges, right? So these are the 2 resonance structures for a carbonyl group that you show. Now remember, the C double bond O bond is more polar than ethers. Ethers में क्या होता है? C, O, C. This is your ether, is it not? Now here, the C double bond O is more polar than ethers. Now high polarity of carbonyl group, it is attributed to resonance. Because it is showing resonance stabilization, this carbonyl group is said to be highly polar. Okay. Now let us come to physical properties. Now among the physical properties, when you consider the physical state, methanol is a gas, HCHO, this is methanol or formaldehyde. Ethanol is a liquid, and the others, they may be either liquid or a solid at room temperature. With heavier molecular masses, they may be solids. Now the second point is about boiling point. Now aldehydes and ketones, just now we saw that they are more polar. They are much more polar than alkanes. RH is alkane, and alkane is totally non-polar. And ether, to some extent there is polarity, but it is weakly polar. Okay, so as and when the polarity increases, boiling point also increases, because more polar means what? Dipole interaction is there. So when interactive forces are there in a particular substance, then boiling point is said to be higher. Okay, and now you find this carbonyl group, it is showing positive and negative charges, right? That is what here you are showing. What you are showing? The negative charge of oxygen is interacting with the positive charge of the adjacent carbonyl group. So this is what you call it as dipole-dipole interaction. Yes, this is one dipole, this is another dipole, this is the third dipole, and there is interaction between the two. And because of this dipole-dipole interaction, you find these aldehydes and ketones possessing higher boiling point. Now look at the boiling point here. Now these are different compounds of comparable molecular masses. This is butane, this is methoxyethane, this is propanol, this is propanone, and this is propanol. Now look at their molecular masses. It is very close by 58, 60, 58, 58, 60 like that. And look at the boiling points. One is having 273, 281 Kelvin, 322, 329 and 370. Alcohol is having the highest. Now why alcohol is having the highest? We have already seen alcohols and phenols. Alcohols में intermolecular hydrogen bonds होती है, is it not? Polarity is also there. Intermolecular hydrogen bonds are also there. That makes the boiling point of alcohol much higher than aldehydes and ketones. And butane being totally non-polar, its boiling point is low. And ether, it is slightly more polar, so its boiling point is slightly higher. Okay, now this is how you discuss the boiling point. Now when you consider, say for example, if I give you C3H6O, what is the C3H6O? C3H6O, it can be written as CH3CH2O. It could also be written as CH3COCH3. So carbon is 3 in number and hydrogen is 6 in number and there is one oxygen. So in simple terms, you can show it as a molecular formula C3H6O. So the C3H6O, it is existing in two isomeric forms. One is propanol and propanone. So remember, aldehydes and ketones, they make a functional pair, functional isomeric pair. Is that clear? This we have seen in 11th class. Yes, functional isomers, then position isomers, structural isomers, all these things you have already done. Okay, now in the case of ketones, what happens? There are two electron donating groups, right? Supposing you show acetone or propanone, there are two CH3 groups attached to the carbonyl group. Now both the CH3 groups are electron donating groups, okay? So isomeric ketones, when you compare it with aldehydes, isomeric ketones, they are supposed to be more polar than the corresponding aldehyde, okay? Now, in general, how do you consider the boiling point? RCHO less than RCOR, that is aldehyde, less than ketone, less than alcohol, less than acid. Now we will see about acid in the coming topic. Is that clear? Now for the time being, try to understand aldehydes and ketones are having lesser boiling point than alcohol, and alcohol is having lesser boiling point than acid. Why this is having the highest boiling point, we will see, right? Now come to solubility. Now in the case of solubility, lower members have been found to be soluble in water due to hydrogen bonding. Now look at the hydrogen bonding shown. This is a carbonyl group and the oxygen of carbonyl group is attached to hydrogen of water through intermolecular hydrogen bonds. Same way the other hydrogen is also attached to the carbonyl oxygen through intermolecular hydrogen bond. Okay, but then what you have to remember, solubility decreases with increase in the size of alkyl group. As and when the bulkiness of this R group increases, then what will happen? Hydrophobic interaction will be more, because of which the solubility will become less. Okay, and as such, since they are all covalent compounds, they are soluble in organic solvents. And a very peculiar property about this is smell. Lower members, they have pungent odor, and higher members, they are more fragrant, and that is why they are used in flavoring agents. Okay, so this is about physical properties of aldehydes and ketones.